Hello everyone, good morning, good evening, good afternoon from everywhere you are. I'm so happy to be here with another session in Microsoft Zero to Hero. I'm Mohsen from Microsoft Zero to Hero, and today we have another great session with a great speaker, Microsoft MVP. Before to kick off the main session, let me share some slide about the community, and after that, start the main session. Today we have a Florian. He's a Microsoft MVP and also he's a Azure solution architect, and he wants to talk about the serverless solution in Azure and the topic, and it's very interesting. Actually, as you know, Microsoft Zero to Hero is a part of Microsoft Learn Community. Microsoft Learn Community is a central hub, a lot of learning content based off your role, based off your certificate. You can choose your learning path. You can ask your question, your solution, or other things from a lot of Learn experts. You can join from aka.ms Microsoft Learn Community. Also, you can follow us, Microsoft Zero to Hero, in social media, in LinkedIn, in YouTube channel, and we have a lot of great news about the future event and future services we want to publish that. Actually, sorry. Uh, Actually, is our April calendar. This is the first session. All previous session hosted on our YouTube channel. You can watch. And the last slide is our code of contact. Be aware of other. Be friendly and passionate. Be welcoming and respectful. Be open to all question and viewpoint. Be understanding on different. Be kind and considerate to other in the chat, in the question or other things. Now is the time to add Florian on the stage. Hello again.
Hi.
How are you?
Fine. A little bit early in the morning, but I'm fine.
Yeah,
I'm happy to be here. So, yeah, what about you?
I'm fine. Thank you. Good. In the backstage, I talked with Florian. You were in the Microsoft MVP last week.
Hmm.
And what about news? What about the new technology? It was interesting.
What it was interesting, yeah. A lot of news, a lot of things I really like, and especially in the serverless environment, there are a lot
Mhm.
of stuff happen, and yeah, I'm looking forward. I think a lot of the information we got will be announced in at Build. I think Build
Okay.
is
Yeah,
this month, next month.
next month.
Next month, yeah. So in May, I guess a lot of news will happen then, and then we can speak in public about it.
Yeah, cool. I know.
So yeah, but I really enjoyed it. It was nice, a lot of information. A hard week, to be honest. It was quite tough, but yeah, I enjoyed it.
Cool, cool. Okay, let me add your presentation on the screen. Yeah, you can start. Good luck.
All right, then. Thank you, and everyone else. Welcome from my side. Yeah, today I want to talk about the topic of serverless. I want to explain why serverless is a great choice, or maybe the best choice for your next Greenfield project, and how you can make this new Greenfield project a success. And the idea of this talk started some time ago when a friend of mine asked me, "Yeah, you're doing serverless, but what is serverless?" And to be honest, I couldn't tell him exactly what serverless is. And I think a lot of you may have the same problem because there are a lot of yeah services called serverless. So, for example, there is a Cosmos DB available as serverless. Okay, but what does it mean? At the end, it's pay as you go. Okay. Then we have, for example, Azure Container Apps, which is as well serverless, some kind of, but as well it's pay as you go. Then we have Azure Functions. Azure Functions are serverless because you only create these function, and yeah, you do not pay for the whole service for the server. You just pay as a pay per use at the end. So yeah, it's as well or every time this paying stuff. And I had the feeling at the beginning, okay, pay as you go, and serverless is more or less the same. But from today's perspective, I would say serverless is not just a technology. I would say serverless is some kind of a mindset, that we think about services as building blocks and think about it as things we do not care about, some kind of. I will explain it later what I mean with this. And this is all about today. I want to explain you I brought two examples of companies which use the serverless approach. They started Greenfield projects with a serverless approach, and more or less both were a success in one or the other way. And yeah, this is today about. I will not show you Azure Functions code, and I will not show you how to create an Azure function or how to create an Azure container app. This talk is really about what serverless is and the idea behind serverless, and how you can use serverless for your projects. I'm a Microsoft MVP. We are here at Microsoft Learn, and unfortunately, both examples are created in AWS. And both examples, the diagrams I brought, are as well with AWS resources. On the one hand, this is because they were created in AWS. I don't think now it's a great idea to adjust it and say, it was created in Azure and all the resources, and then you have a look and then you see, okay, no, it was not. And on the other hand, everything you can do in AWS, to be honest, you can do it in Azure as well. I will explain you which service is in Azure. And my idea and my hope is, when I explain you that AWS is working with this stuff and other companies using AWS, and I say, hey, in Azure it's possible as well, I hope that a lot of people say, okay, then we tried in Azure for sure. So and as I said, it's only the examples, the diagrams. It's not about the topic. Everything I explain is possible in Azure, and I did it in Azure as well. So, but now let's start. First of all, I brought a survey of Gartner and Deloitte, and they found out that software development in today's world is only 40% about value creation of a developer time. So in other words, only 40% of your time as a software developer, you're creating value for your end customers. And maybe you think, no, this is not true. I deliver 100% of my working time value. And I would say this is not possible. Maybe you have 50%, maybe 60%, but then you have colleagues which only create 20 or 30% value. And this is a hard number, I would say, because I think this is quite low. And I was a little bit shocked at the beginning when I found out that only 40% is about value creation. But what is the result at the end by only having 40%? It's at the end that our time to market is slower, because when we have round about half of our time only value creation, then it took at least double the time to bring something to the market. We have less value creation, and for sure at the end a customer will be unhappy as well, because we could do more, we could do it in better quality and faster time. And at the end, I think this is something we should change. And I will show you now which jobs we as software developers do today. And then maybe you find out what is this 40% of your time. First of all, I want to start with the two obvious ones, and I would say the two we as software developer really love. It's for sure coding and maybe data structure. For sure, coding was what we as software developers love, I hope. I hope that most of software developers love coding. And for me, to be honest, it was the beginning of my journey as a software developer, as a software architect. I loved coding. I loved just sitting around, coding some stuff and learn something new and build something from scratch. And this is what I really like at in the job as a software developer. For sure, defining data structure is not the greatest stuff, but we want to store data somewhere. And from this perspective, okay, it's part of the job. It's as well more or less coding. So I like it as well. I love it. It's okay. But then we have more. For example, defining a CI/CD pipeline. Because after coding, after defining data structure, we found out, okay, it's nice that it's working on my local machine, but at the end, I cannot ship it to a customer. I need to bring it to the world. I need to somewhere host my application, and this is working best case via CI/CD pipeline, doing it automatically. I just do it once and not multiple times manually. So creating a CI/CD pipeline is a good way, I would say. Next thing is deploying the infrastructure. We need to define the infrastructure. We need to define which resources we need, and then we need to deploy it and make it online available for sure, so that we can ship our code to the infrastructure. When we have a virtual machine, for example, or a complete server, we need to somehow set up our operating system. We need to decide which operating system do we need. We need to install it. We need to ensure that everything is working fine. And for sure, we need to add network routing. When we have a virtual machine in our local on-prem server, then we need to think about networking. And as well, when we use Azure, there is a private network possible. So what about our routing? And when we discuss about routing and networking, we need to have in mind that network security is on-prem and in Azure a big topic. So we need to decide which services has a connection to the internet, which services can be connected and called via the internet. Maybe we have a database and we say, no, database is only available via this private network. These are things we need to have in mind as software developers today. And then security patches. Again, when we have a virtual machine, we need to think about security and all this stuff in our virtual machine. We need to make patches. We need to update our operating system. We need to ensure that there is no public port available. And everything is something we have to have in mind. For sure, we need to somehow monitor our system. If it's a virtual machine, we need to have bigger monitoring systems. When it's just an Azure function, for example, it's quite easy. We just check the application itself because there is no infrastructure we need to handle. But at the end, we need to think about it. And for sure, there is our most loved topic as software developers. We have meetings. So at the end, I think there are more and more bubbles we can create. There are more and more tasks we as software developers have. And when you think about it, I would say there are only 4 topics which really brings value to our customer. When we think about it, coding is something which brings value, because at the end, by doing some code, we bring value. We bring some new features, so coding brings value. Defining data structure as well, because when we have some new code, some new functionality, we want to store data somewhere, so this is important as well. CI/CD pipeline is something I would say, it's important because we just define it once. Then our code is shipped automatically. We do not have to do it all the time manually. Then we have failures, all this stuff. So this is something as well. And unfortunately, meetings is important as well and brings value to our customers because, when we have a meeting with a colleague and we can just discuss about the feature, it's better instead of just code 2 weeks. And after 2 weeks, we found out, we didn't understand the requirement correctly. And at the end, we need to change something and then it takes longer. So meetings, to be honest, brings value to our customer. But everything else does not bring value directly to our customer. Please don't understand me wrong. Network routing and network security and infrastructure monitoring and infrastructure for sure, These are really important topics, but these are not topics which a software developer should focus on. A software developer should not focus on monitoring the system or creating network security stuff. Honestly, for me personally, I think a software developer should code, define data structure, have meetings, maybe defining CI/CD pipelines and creating them and let them run, but everything else should not be the job of a software developer. And this is what serverless brings to you. So now I talked a lot about what a software developer's job is and what serverless can bring you. But let me introduce myself for a few seconds. I'm Florian Lenz. I'm a Microsoft MVP and freelance Azure consultant and architect. And I'm mostly focused, as I said, on Azure, on developing .NET C#. I do all my stuff with Azure Bicep or Terraform. And I'm working more or less daily with Azure, and I really enjoyed it, and I like it. So this is why I'm an MVP for Azure, I guess. And like today, I'm a speaker at conferences, user groups, etc. And when you want to get in touch with me, I have a LinkedIn channel, I have a YouTube channel, and my personal website. To be honest, my YouTube channel is at the moment only available in German, but there will be some news in, I guess, 1 or 2 months, because I will start a YouTube channel in English as well. And when you want to get some information afterwards, when you have questions, feel free, write me an email, write me a message on LinkedIn, wherever. I really enjoy to help and to give some information when something's unclear. Now let's start with the idea of serverless. The idea of serverless is to have components, I would say. So components can be a building block. So as you can see in this infrastructure as code, you say at the end, I need a function, for example, an Azure function, and you get an Azure function. This is it. You get, at the end, there is a server somewhere in the Microsoft center. So somewhere there is a server for sure. And there is as well, for example, Linux or Windows running on this machine. And there is your code running on the machine. But you only see the Azure function. So there's for you only the small piece of a function. You do not care about the virtual machine. You do not care about the server. You just care about your small piece of code, your small function. You monitor your function, and everything else is the job of Microsoft, of Azure. You just select your managed service, in this case an Azure function, and you get it. It's the same for a Cosmos DB or for every other platform application as a service. At the end, you can just select your components you need. You get these components and you do not need to manage the server. You just define what you need, and at the end, you get what you defined. So when you define multiple functions and an application RP management in front of all these Azure functions, you get it as defined. This is at the end infrastructure as code. And for me, infrastructure as code is highly important when you use serverless, because only with this approach you can define what you really need and you get it all the time in the exact same way. And furthermore, it's super fast available when you think about it, but this is some cloud topic for sure. When you think about it, when you buy hardware physically, it takes some time for shipping and all the stuff. When you use some kind of cloud provider, you just say, hey, I need the following, I need an Azure function, you get the Azure function. To be honest, a virtual machine is the same, but here this is a part of this select building blocks. Okay, and now we only talked about Azure Functions, and Azure Functions are serverless, maybe or maybe not. And then we have static web apps, which is serverless or not. But what about a REST API we call? And I think calling a REST API is as well some kind of serverless, because at the end, I do not care about the application behind this REST API. I just call a REST API. There is a result I expected, and yeah, when it's working, it's fine. And when it's not working, I just say, hey, this is not working. Please ensure that this is working again. And I had a friend, and he developed a startup, and he developed software for the startup. And they started with this approach like, we want to use as much as possible available in the internet, so services, REST APIs, and we only code when it's really necessary. And this is the kind of serverless mindset I like. Because at the end, why should you create a complete payment flow for PayPal, for example, when you just can use a REST API for it? Do not clone and copy all the stuff which is already available only to run it by yourself. I mean, there are reasons to make it this way, but most of the time you can just use what is already there. For sure, when you use 100% serverless and pay-as-you-go models, there is some kind of vendor lock-in. So you have a dependency to this cloud provider, and you need to have this in mind. You need to have an exit strategy that when, for example, something is not working fine for you anymore, that you go and switch this. And for sure, there is complexity as well. It's not just, yeah, I have an Azure function, this is it. You need to know a little about Azure functions. You need to know it about API management and all this stuff. So it's not just like, this is my Azure function and this is it. But I think it's worth it. Next thing is about costs. And as I already said, it's pay per use at the end. So you only pay what is really in use. Pay per use or pay as you go is everything you can use based on the request. So for example, an Azure function or compute resources like container as a service can be used with this pay as you go, which means you pay per request. When I have the number right in my head, it's about $5 for 1 million requests for Azure functions, for example. So I think $5 for a million requests is okay. And for databases, for example, like Cosmos DB, you can use as well a pay-as-you-go approach. The advantage is that you only pay for the traffic which really happened. So as you can see in this picture, we have the line under the red area, and this is the line which is the real traffic, and the bold black line is the thing we pay for. So at the end, we have only this small area of red between the real traffic and what we're paying for. And as you can see, the scalability is quite good. And on classic approach, you would say you would pay for a lot of servers, and you have maybe just this traffic pattern, but you will pay for a server. And no matter if the server has only 20% usage, 50% usage, 80% usage, you pay always for 100% usage. With pay-as-you-go, you pay only for the request which really happened. With this approach, you can as well have an always with this approach, you have always enough resources. No matter if you have only one request, you can handle this one request. You pay for this one request. When you have 1 million requests, you pay for 1 million requests. So at the end, you have scalability out of the box. And you do not need to manage the scalability. You do not need to configure it. You just say, this is my Azure function, and out of the box, scalability is available. One problem, for sure, when you have an app and it's developed 100% serverless with pay-as-you-go, you make an advert on TikTok, you go to bed, and next day you wake up and you see, oh gosh, what happened? You have, 10 million new customers. Then you pay for all these 10 million new customers. And when this 10 million new customers use, 10 or 20 requests, you have, for example, 20 million or whatever requests. And you need to pay for it. So at the end, when your app goes viral, your costs will grow as well. And in this situation, pay-as-you-go can be a challenge and a gift at the same time. Because the challenge is now you have a lot of money to pay because there are a lot of requests happened. But the gift is, it's scalable. You do not ensure that you have enough resources. On the other side, when you just say, hey, there's one virtual machine running, this is okay, then this virtual machine maybe cannot handle all this traffic. And then a lot of new customers will leave your app and say, oh God, it's not working, it's too slow, whatever. So you need to think about it and have in mind that pay-as-you-go has challenges and advantages, and you need to find the right spot for you. And there's one more thing. I guess it's okay to say serverless and pay-as-you-go is not the right thing for you. And this is when you as a customer or your customer say, hey, I want a fixed price every month. For me, it's important that I pay, for example, $2,000 every month on a fixed pricing model. I don't like that it's, sometimes it's over, sometimes it's under that. In such a situation, it could be that it's more important, and then I think, okay, then serverless is not the right thing for you. I have a customer, and the customer said, no, we are fine with paying more for our resources, but for us, it's highly important we have the same number more or less every month. And in this situation, my only job is, okay, when you are fine with paying more than needed, then go for it. They did, they were happy, so I'm happy too. And now, today I talk a lot about serverless, and I really like serverless. And maybe you think about, hey, Florian is talking about serverless, and serverless is the best and all this stuff. But please be aware, if your only tool is a hammer, then every problem looks like a nail. So what I want to say, serverless is not a silver bullet. Serverless is a good starting point for a Greenfield project. Because at the end, you have pay-as-you-go, so you have always enough resources you do not need to care about. Serverless is great for non-customer facing apps. So for example, when you just have backend processes, this is quite nice as well. When you have message-based system, it's nice because serverless, you pay for the request, and the request is as well when a message comes via a message bus. So this is where serverless projects are really great, but as well, there are projects which are not such a great deal for servers. So for example, customer-facing apps could be a problem. When you have an application, for example, a business application in your company, and the application starts at 6, 7, 8 o'clock in the morning. So when the first employees came in, the application gets some traffic, and there is lunch during 12 o'clock. So you have a small spike with less customers using the application, then it going up again. And around 5 o'clock in the evening, the traffic goes down again, and nothing happened. In such a case, to be honest, serverless is not right for you. Just use the virtual machine which can handle all the traffic, which is under 80% load all the time, and then this is it. This is totally fine. But when you do not have this information, starting with serverless could be an idea, but please have in mind as well, serverless is not a silver bullet. And when every problem looks like a nail and your only tool is a hammer, then maybe this is not worth it. So please do not use serverless just to use serverless. Have in mind, what is your requirement? What are your information? Is serverless a good fit? If yes, use it. When you have more information and you think serverless is not right for you, then please do not use it. So, and by using serverless, I say you can focus on building applications and not on maintaining servers. This is what you can get from serverless. And one company which did it in a quite impressive way is Coca-Cola. Maybe some of you know this machine, maybe some will not, so I will explain it. This machine was developed for, I guess, 20 years ago from Coca-Cola. It's called Coca-Cola Freestyle, and it's a vending machine where a lot of brands of Coca-Cola are available. So at the end, you have Coca-Cola, you have Fanta, you have Fuse Iced Tea, you have Powerade. So this brands you see, and a lot more. and you can mix it however you want. So at the end, you can select Coke Cherry Vanilla, and then you add a little bit of Fanta Orange and a little bit of Powerade Lime, and you can mix it all around. And after that, you have a drink, which is not available somewhere in a store because you mixed it completely by your own. In Germany, there are some restaurants like Five Guys, for example, having this machine, some cinemas having this machine. And it's quite nice. To be honest, I like it because it's something new. It's something you cannot get when you just go to a grocery store, for example. So I really like this machine. And Coca-Cola liked it as well, I would say, because it's still available today. So after 20 years, everything's fine. But there was a problem some years ago in 2020 when COVID happened, because Coca-Cola found out that less and less customers are using this machine anymore. So they thought about it, okay, why are people not using the machine anymore when they're going to a restaurant but not having some drink? Why is this happening? Why is there a spike? So what happened? What is the problem? They made a survey, they made research, and after some while they found out, the problem is that people think by using this machine, they can be infected with COVID when an infected person used the machine a few seconds before. This was a problem Cola found out. They need a solution for it. And then they started about, okay, what is a solution? And as you already can see in the upper left side, there's a small QR code. So the solution of Coca-Cola was, maybe we just bring a QR code on every machine. The customer can just scan this QR code with his phone and use the machine by using his phone. So the customer do not touch the screen. They do not touch the button to pour. It's just, here's your phone, click on your phone and everything is fine. You can get your drink without being infected. Everything is cool. And Coca-Cola thought maybe this is a great idea and we should start with this. And now the question, how do you start such a project? Okay, there are a lot of customers using your machine, but to be honest, you do not have any data or metrics if customers use this new, I would say, web application. You do not know if customers say, oh yeah, this is a solution. This is why I want, or with this solution, I will use this machine again and I will scan this QR code. What about elderlies which do not have a QR code scanner on their phone? Maybe this is a problem. I don't know. So at the end, you do not have any data. Furthermore, you have time constraints. How long does COVID stay? Is it in 2 months gone and then we developed something and it's not worth it anymore because people are using the machine again? Or is it staying for multiple years? Turns out it stays for multiple years. But okay, so what is about timing? We need to have a quick solution. We need to have a quick fix so that people can directly use it and we do not have time to wait 2 years and develop it and bring a perfect product. No, we need a quick solution because we do not know how long this will stay. And at the end, there are budget constraints. I guess in every project there's a budget constraint. It's always about, please, it should be cheap and not too much effort. And please be as cheap as possible. And for sure, no upfront costs. So Coca-Cola didn't want to have any upfront costs. They do not want to buy a server for this. They do not want to buy hardware. So it should be cloud native with cloud resources and all this stuff. And with these 3 problems, so no data, time constraints, and budget constraints, the solution was going serverless. And I will explain you why. First things first, this is the whole resource infrastructure Coca-Cola defined. So at the end, the first step is you have a QR code on every machine. You scan it with your phone. Next thing is that the web application stored in an S3 bucket is delivered via CloudFront and the web application firewall to the customer's phone. And then you have step 3 with this application and in backend, you just get all the information about available drinks, and you can control the machine by using an AWS Lambda function. This is what Coca-Cola defined and which is currently working as well. And this is, to be honest, this is working at the moment in Five Guys stores all around the world with a QR code. You can use exactly this process when you go to a store and use this QR code. I already did it in Munich last year. So this is it at the end. So only 6 resources are used for this project. So as I said, this is AWS resources, and I will explain you which resource it is in Azure. So an S3 bucket is at the end just a blob storage. In this storage, you add all your static web app files. So for example, when you have a view application, you can just add all your view application files. A cloud front is at the end a traffic manager. So some global load balancers, content delivery network. And web application firewall is as well available in front door, for example, in Azure. And this was made to have a secure, fast available front end. The backend part is about API gateway. So it's API management, for example, in Azure. AWS Lambda is an Azure function, and the DynamoDB is a Cosmos DB. And with these resources, you can create this example by your very own. And as I said, it's as well possible in Azure. You do not need to use AWS for this. And I hope that more and more companies which are using Azure already think about serverless as well and using serverless, so that we can have in a few years such an example with Azure and not with AWS, because I would really love to see such a solution in Azure, to be honest. This is what Coca-Cola did. As you can see, 6 resources, and what they did just define these building blocks. They just said we need an S3 bucket for our data. We need a CDN to deliver this web application. We need a web application firewall to make it secure. We need an API gateway in AWS Lambda, a DynamoDB. They just defined these building blocks, and in this case, AWS ensured that everything is working. Everything is up and running. Everything is secure. So you do not care about it. You just say, this is what I need, and I focus on code. This is what Coca-Cola did, and it's working. Today the app is available. As I said, I used that app in Munich last year, and I really enjoyed it, that I know in the background everything is working serverless, and it's not the classic way, I would say. And especially that a company like Coca-Cola is using a serverless approach was really great to see. But the really important stuff is, how long does it take to build the first prototype? Coca-Cola built the first prototype in just a week. So after 1 week, Coca-Cola had the first solution and the first idea and said, hey, this is our idea. Product manager, what is your opinion on it? Is it working? Is it not working? Do you have any feedback? And they could use the feedback after 1 week. And this is what I really love about serverless and this approach, because at the end, having a prototype after 1 week is super. I'm just impressed by this number, because at the end, every time I work on a project, it's about, it takes a month until we have a first prototype and we can show it somewhere. But by using serverless, you have it in just a week. Okay, this is now a really small solution, but as well, when you have a bigger solution, maybe in 2 or 3 weeks, you have a solution which is a really first step in the right direction, or you get feedback and see, okay, maybe we need to change our direction. Even more impressive, after 100 days, Coca-Cola released the final solution. So it took just 100 days from kickoff to release, bring this QR code to all machines, starting with this approach, and find out if customers are using this application and if more and more customers are using this machine again. Coca-Cola did it because of this serverless approach. So software developers could focus on business creation, on business value creation, on delivering fast, and not on doing infrastructure stuff and monitoring and check why the CI/CD pipeline is not working or why deployment is failing, whatever. So they just focused on building code, on writing code, building this application, and focusing on business value. So at the end, by using serverless, what you get is, first of all, always enough resources. Because Coca-Cola used serverless, they know we do not care about the number of customers who are using this new application, because we have always enough resources. When 1 million customers are using this QR code solution now, we have enough resources. It's scalable. The scalability is there. It's not a problem. We do not care about this. We are fine on this side. Everything is okay. Next thing is we pay only for our request. So at the end, it's not a problem when, for example, only a few customers are using this machine. When only 1,000 customers are using the machine, okay, then it's a question if this was a success creating this application. But at the end, we do not have a lot of virtual machines or servers running and we pay for all these machines. No, it's only the request. So when there's only 1,000 requests per day, okay, it's only 1,000 requests. We pay for this. It's okay. This is it. But even more important, and this is why I would say serverless is such a great idea for a new project, you can collect data and metrics. Because as I said at the beginning, Coca-Cola didn't know how many people use this machine. So to be honest, every number they thought about is wrong, to be honest, because when no one agree that, we found out that 1 million customers are willing to use this machine, okay, then you have this 1 million, but you do not really know, because only a customer say, I use this QR code application. It's not 100% sure. By using serverless, you can start with always enough resources, pay per request, and collect data and metrics. And with all this data you collect and the metrics you get, you can think about it after some while and check if your architecture is the right selection anymore. Is it still working? Are your assumptions still fine and valid? And with serverless, you get an evolutionary architecture. You can create an architecture, you can think about your requirements, and after some time, with all your information you got, you can check if it's still valid, and if not, you can change your architecture. And to be honest, you need to change your architecture. At the end, I think this is something a lot of customers are not using today. Having an evolutionary architecture. I had a customer some time ago, and the customer is a German company. I think you do not know it. And this company has had 1 million customers 20 years ago, I guess. So 1 million customers, they thought about, we need a new application. They created the application. Requirements are that, for example, 5 million customers should be handled with this application. And they created the application. Everything was working. Application is still working. Everything is fine. But no one was really updating the software. No one was checking the requirements and updating the architecture. And today, the customer has 20 million customers working on an application which was created for 5 million customers. So at the end, today, the application is slow. The application is not really working. It's hard for customers to use this application. And now they are doing a complete rebuild and building everything new because, it's not working anymore. And by using serverless, you have out of the box this evolutionary architecture. You need to check in certain intervals if your architecture and your requirements are still aligned and on the same path. You cannot just say, I just created it once, everything is working, we do not have a problem. We created it once, architecture is fine, we just code and this is it. No, you need to think about it. And the next example is exactly about this topic of this evolutionary architecture. And maybe you already know it or you do not know it, but it's AWS itself. This is the headline of an application. You think everyone knows. It's Prime Video. And Prime Video or Amazon created this blog article some while ago. And this article said, scaling up the Prime Video audio-video monitoring service and reducing costs by 90%. So what does it mean? At the end, Amazon says, by using a monolith architecture and a monolith application, we could reduce our costs by 90%. And when you just read this headline, you may think, why should I use microservices? Why should I use serverless? Hey, I just use a monolith. I have my virtual machine. Everything is fine. And to be honest, this article was a little bit, clickbaiting, because when you read the article, you found out it's not 100% what Amazon write in the headline. But let's have a look to what Amazon write, what the problem was, what the application was, and what the solution now is. This is the audio video monitoring service designed at the beginning. So before they had this monolith architecture changes. The service is about checking every customer's audio and video quality. So at the end, when you as a customer of Amazon Prime watch a video, every single frame goes through this service, and the service is checking if the quality of your video and of your audio is correct, and if everything is fine. And if yes, nothing happened. If not, there is some new process going on and checking why this is a problem, so that you have a great experience watching a video. So what happened? When you watch a video, there is this audio frame going to a media conversion service. The service splits video and audio frame, and both frames are stored in an S3 bucket, so a blob storage again. Then there is a step function. This is an Azure doable function at the end, and this function starts the video monitoring function and the audio monitoring function. Both functions querying the frames from the S3 bucket, doing their quality checks, and after checking the quality, they store everything in an aggregation function, and the aggregation function stores the final result in an S3 bucket again. This is a solution. Okay, where is the problem? The problem is this 5 times using S3 bucket. They store 5 times, or they read and write from an S3 bucket 5 times. And when you know about serverless and pay-as-you-go, then you know in this single process, we have 5 times writing or reading data from an S3 bucket. We have 5 times calling an AWS Lambda function, which means at the end, for one single process, we have a lot of read and writes, etc. And this is maybe not the best idea. Let's have a look to numbers. When we say we have 5 times read and write operations for a single frame and at least 24 frames per second, this means at the end we have 120 read and write operations per second per customer. And when we think about that, that Amazon Prime has 200 million customers all around the world, I think it's possible that at the exact same time, at least 10 million customers are watching a video on Amazon Prime. And when 10 million customers watching a video at the exact same time, there are 1.2 billion read and write operations per second, and in addition, 1.2 AWS Lambda invocations per second as well. This is a number where serverless is not working anymore. And when you have a look to this, 5 calls, this for sure in with less customers, with a few customers, this is not a problem. But the more customers you get, the bigger the problem is. So at the end, you need to think about it. And yeah, when you ask me, this one is why this 90% reducing cost by 90% is possible, because this number is so high, for sure you can optimize it somehow. But was it a problem to start with this? No. This is my opinion, and this is the opinion of ex-Amazon VP Adrian Cockcroft. He said, the Prime Video team had followed a path I call serverless first. I don't advocate serverless only. And this is as well what I think. Amazon Prime Video audio video monitoring service started with an idea, with a first proof of concept. They had the goal in mind, okay, we want to ensure that every single frame we send to our customer has great quality. And we want to have a fast solution. We just want to bring it out as quick as possible. And when everything is working, we are fine with it. They started with serverless. Everything was working. Everything was fine. Cool. Never touch a running system, as we know. But after some while, they found out we have problems. We get more and more customers. The pricing is going up. Maybe we need to change something. And with all this information they had, so they know exactly how many customers are using this, are using at the end Prime Video, how many customers, how many requests happened in the system, what is the best solution. And with all this data and metrics, they found out that a monolith architecture could be a better solution instead of using just serverless components. So at the end, it's exactly this approach, starting with serverless, found out if the solution is working for you. And when this is the case, take all the data, all the informations you have, and adjust your application, improve your architecture, and find a better solution like Amazon. And now, as you can see, it's just an Amazon ECS. So at the end, it's an Azure Container App, for example. It's just a container running somewhere in AWS. And now they just moved everything in a single process. And by using this approach, they changed the way of storing and getting data. So at the end, now they do not store data anymore in S3 buckets and writing and reading them all the time. The frame is going into the process of the container. Inside the process, they send all the information around. So there's no read and write with other services. And at the end, there's just one write method to the S3 bucket for the final result. So they reduced the usage of S3 buckets by 80%. Furthermore, they reduced the invocations of AWS functions, Lambda functions, as well on 80%, because now they just trigger once this container, this application, this orchestrator, instead of 5 times function, step function, monitoring function, all the stuff. So it's as well an 80% advantage. At the end, this is why 90% optimization was possible. And now, I think this is exactly why you should use serverless. Serverless is all about ups and downs, and this ups and downs brings you further in the future. I think you cannot design a perfect architecture from the beginning. You need to start fast. You need to find a solution and get feedback from your customers. And with this feedback, you can improve your architecture from time to time, have an evolutionary architecture, and by this, you will be faster instead of just going all the way and doing it every time the same. This is what serverless is. Starting fast, collecting data, find the right solution, and then it goes down very fast. It's going up and up and up. And then you're slow, and then you figure out, okay, here is my data, here's my metrics. Maybe I should change something. You change it, your architecture is improved, and then it's going faster again. And then it's going slower and slower, and then you find the next better approach. This is what the serverless mindset is all about. And by using serverless first, you should start with aligning your requirements, get as much data as possible, and when there are data, use it. When there are no data, the best decision, use serverless. You do not care about how many customers are using your application. You do not care if scalability is possible or not. There's everything out of the box for you. You design your architecture, you build your application, and with this information, you can collect data and metrics to realign your requirements and designing your architecture again. This is the process of serverless first. This is the process Coca-Cola and Amazon Prime used in their projects. And as you can see, the one solution is still running serverless. The other solution is now in a monolith architecture of containers, but they find this perfect solution, this currently perfect solution, because they started with serverless. Otherwise, maybe they started with something else. They started with microservices and containers, and now they have a big ball of mud with all the services. No, they have a clean monolith architecture because they started with serverless. And at the end, by using serverless, teams can deliver value 20% faster. I hope you learned a lot. When you liked what I talked about, have a look to my YouTube channel in, as I said, 2 months. There will be an English version then. I have a podcast. To be honest, it's only in German available, but maybe when someone German speaking is listening, have a look there. And as well, when you are in Cologne, it's a warm welcome and an invitation for you. I have a meetup there. So if you're in Cologne, come to my meetup and let's talk about serverless and all this stuff. Thanks again. And for you, have a nice evening. For me, my day is starting now.
Great. Thank you very much again. It was a nice presentation, and there are a lot of positive comments about your presentation. Let me show for you about some guys. Guys, if you have any question, you can ask in the comments. If you have any question for future, you can connect with Florian in the LinkedIn email, and also you can ask your future question. Okay, it seems there is no question in the chat, but we can end of this stream done. Okay, thank you, Florian. Again, thank you very much. Thank you, guys. Okay, Florian, is there anything you want to share?
Not from my side. It was a pleasure to be here. Thanks for having me again, and looking forward to our next session.
Okay, great. Thank you, guys. Thank you.